Yeah, let me tell you about one sort of exciting new idea. So I sit on two centers, right? So I work with the Center for AI Safety and the Center for Automated Reasoning. And recently, there's been a new line of work that kind of brings these two together. And I think this is quite exciting, so I'll tell you a little bit about it. In automated reasoning, we have these tools that can precisely answer, whether a set of mathematical equations, possibly coming from real computer systems, has a solution, right? But you get an answer, you get guarantees. All of this new AI stuff can do all sorts of fancy things, but you don't get guarantees, right? So if you run your favorite ChatGPT, it'll give you an answer, but it might hallucinate. It might give you a completely bogus answer. And so the question is, can these two worlds help each other? And we've been exploring two directions along those lines. So one is, can we use sort of AI and machine learning to help accelerate these automated reasoning tools? And the answer is yes. So we have some recent work where we use machine learning to sort of learn what are the right hyperparameters if you're going to run these tools, and we're able to speed them up. Okay, so that's one exciting direction. And then the other direction, which I think is maybe even more promising, is can automated reasoning sort of help fill this gap in where AI might do something wrong? So the whole premise of the Center for AI Safety is trying to address this problem. If you have a neural network or a machine learning system, how do we bring these rigorous mathematical guarantees to those kinds of systems? And we've done a lot of pioneering work on that. With these new chatbots and large language models, that's an even bigger challenge. How do we make sure that they are producing something that's really accurate? And as a first step, we've looked at large language models being used for code generation, right? So if you ask, GPT-4 or one of these other large language models, please write the code for this, it actually is amazing. It can actually do it. It'll write a bunch of code, and most of the time it's correct, but not always. So now you have this question, well, how do we make sure that this code being generated by AI is correct? And what happens if it's not? Well, what happens if it's not is all the same problems we've always had with incorrect code. And just the way people make mistakes, these LLMs make mistakes too. So maybe the answer is the same thing, right? These automated reasoning tools can come in, they can prove the correctness of the code, or show that it has bugs. And what's even more exciting is, in order to apply these formal techniques, in the past it's taken a lot of human expertise to write down all the correct logical specifications. But we did an experiment where we asked the LM to actually generate not just the code, but also the logical specifications. And it can actually do this. So now what's great is we sort of have each tool doing what it's good at. So the LLM can create the code, it can create the specifications, but we don't trust it. Then we take our automated reasoning tools on the generated code and specifications and we check it. And if it checks out, then we know we were able to generate the code, we were able to check that it's correct, and now we have fully verified and generated code. So I'm excited about the prospect of a future where we can use these powerful new AI tools to generate things, but we can have the safety and security that's promised by these automated reasoning techniques.